Alright, so I've been watching a lot of YouTube videos on automated blast gates, and I have come to the conclusion that for the most part, most of them don't understand or have never built equipment using air cylinders. You will damage most of the components of a blast gate made of metal or plastic. Irrelevant if you do not control the air pressure in and out of the gate system. My system has, similar to most of them, has air cylinders, just like most of the systems do. But the very big difference between mine and others is it has what they call flow regulators on the cylinders. Now these flow regulators have different functions depending on which one we're looking at. So this one actually has a control gate that prevents, that allows you to do stops in the middle of the opening and closing, so you can actually control the gate exactly. The back one just simply stops flow one direction, so it's actually outflow from the cylinder. So when I push this button right here to override the system, this is a 5-way solenoid valve, and it has a bypass that's not electronic. You'll notice the gate opens very cleanly and smoothly and closes the same way. Now, what's happening is, instead of all the pressure just rushing in and all the air rushing out of the other side, these gates, these flow regulators, prevent the air from leaving the cylinder at a very high rate of speed. They're perfectly controlled by this little hand knob. You can control exactly how fast and how quick. So if it opens too fast or closes too fast, you can open this up and you can control how fast it opens and closes. If I crank this even higher, it will close even faster. And if I crank this way down, almost to the end, now it will close incredibly slow. And you can control this very exactly depending on what you're trying to do. And so as I've been watching these videos, I've noticed that a lot of them have used single acting solenoids. Not only are five-way acting solenoids cheaper because they're readily available and used in almost any electronics assembly. This is one I found on, it's a 12-volt 5-way solenoid. I found it just cheaply on Amazon for a whopping $8. I said they work great. They do have a limit. They require pressure close to 40 psi for them to operate correctly. So you will need a pressure regulator. I don't like to run the gates any higher than what I absolutely have to. They don't need that much power to even open and close them. But the solenoid does not function unless the solenoid valve won't function unless it's at that pressure. As you can see, it looks like I'm, kind of complicated, but it's actually not very hard. What's happening here is this is the gate release. This is what allows, if I wanted to, this is just connected right now, straight into the line that feeds the rear gate control or regulator. And so this second line comes and connects to the front regulator. And what this does is it opens a check valve that allows the front regulator to feed its air back out of it. This line, if you want to control the gate so that it only opens a quarter or 3/4, this line is how you do it. You would actually put a second regulator on this line alone and basically shut the flow off to this line. This check valve would close, not allowing any air out of the cylinder, and this cylinder stops wherever it's told to. You can control it very, very accurately that way. There's rarely any time I've found that I need a gate like that, but these were fairly insignificant and cheap, and so I bought them in case I ever wanted to. Possibly on some of the 6-inch blast gates. I may go that route. The reason I didn't buy any systems out there was because the cost of the system runs about twice what these cost to build, but they only come in 4-inch. I said I can't find a system that even offers a 6-inch unless I want to spend about $500 per gate. So this system runs about $65. I'm working on a polycarbonate version of it that includes the gate and the cylinders all in polycarbonate. It will drop the price to about $30 per blast gate, and I've been designing it for a little while. I'll get that up and going and give you a video of exactly how those work. But the advantage to the polycarbonate is it's see-through. That's what this is. And polycarbonate is the bulletproof, basically what they use to bulletproof glass. It's layered with actual glass. In most cases, there are other options out there, and polycarbonate is not, if you've ever worked with acrylic, it's very complicated. It drills and cracks very easily, but polycarbonate does not. It's incredibly easy to work. Table saws and wood tools work great for it. It's incredibly strong. It doesn't crack, it doesn't fracture. You can drill it, you can tap it, you can do about anything to it. For my sanding table, I have a simple on, off switch. Nice thing about this one is I can control it right here rather than having to go around the machine and open the gates. Flow regulators. Flow regulators have a couple of different options. You have out control and you have in control. When this goes in, full pressure goes in. When this releases, it controls the outgoing air out of the cylinder. So it basically can equalize the pressure on both sides of the ram and stopping the cylinder from moving. That's exactly how it works. The 5 ways, 2 of the ports are simply for exhaust. I use one of these little brass filters just to keep sawdust out of it. But I mean, so you're actually really only connecting 3. The other 2 are just exhaust ports, and they're exhausting the opposite side of the cylinder is how they work. So that's why they have 5 connections. The one here, right here, is your inlet. These 2, A and B, which is marked on the top, those are your outs to the gate. The gates can either be normally closed or normally open. That's up to you. If the solenoid isn't acting, they can either be closed or open. Just switch A or B. And then these other 2 ports right here coming out on both sides. This one comes into a connector, and this is just simply so that I only have to use one. Both these gates are connected together, so they'd only have to use one filter for both gates. But the electrical is fairly simple. It's 12 volt. This is just some sensor wire that I picked up. It's just a yellow 3. It's got 3 wires inside of it. It's got a brown, a blue, and it has a black. And there's just 2 of them coming down right here, so I've got 6. Both blues connect to one, both browns connect. With the solenoid, since it's electromagnet, both wires are black coming out of it. And the whole reason for that is it doesn't matter which one's positive. All it does is charge a magnet and depress some of the pressure off the one end, and then the valve opens. This is my home-built Cyclone separator. Works great. Right here off this one blast gate is my planer, and that was the worst thing in my shop, was that planer. And so the dust only travels up this small vent and into my separator. And the separator has, usually when I run it, I'm only usually one tool at a time. I'm only one person, so I don't have a lot. But the intake is a 6-inch intake going into a 4-inch port going into the dust collector, into the planer. And that makes it so I don't have to empty that bag very often off my dust collector. The trash can simply gets removed from these little lifts, just lifts it up, pulls that off, the trash can comes out. It's just sealed with regular door, 3/4 inch thick door seal, something you can pick up at the local hardware store for next to nothing. One of the things that I've been questioned about or been asked about is this. This is just regular run-of-the-mill stuff you can pick up from the local hardware store. Duct. It has the split seam that goes together. Like I said, as you can see, it's taped off completely. There's no leakage. I've had no problems with it compressing, collapsing, or anything that I've heard quite a few times. You can't use it, you can't do this, you can't do that. I haven't had any of it. It's only 6-inch. I'm sure if you're running 12-inch, I'm pretty sure just because of the force involved when your dust collector's on, you would probably more than likely blow, crush a 12-inch pipe, but 6-inch, it doesn't seem to have any problems.